This is a recorded demonstration of Cyber Crucible's kernel level protections against malware like ransomware, as well as their AI data acceptable use functionality. What we have here is a Windows 11 virtual machine that is almost brand new with nothing installed on it except for the latest updates, as well as some ransomware sitting here zipped on the desktop for use later, and some files that have been seeded on the disk to be potentially attacked by the ransomware and attempted to be encrypted, as well as different types of documents to be potentially accessed and uploaded to or read by AI tools such as Copilot or ChatGPT or others. In this folder, we have different types of documents with different types of protected data like PII and other just protected information, some of which contain MIP labels and some of which have no data classification or MIP labels embedded inside of them, as well as a PowerShell script which can be used to read the MIP labels from any local file. So to go ahead and get started, I'm just going to start installing Cyber Crucible, which is a really quick and easy process. You select the group for which you want to deploy on an endpoint, as well as the installation type. I'm going to go ahead and use the default of a PowerShell script. And while this is running, it's important to note that there are PowerShell script, batch file scripts, as well as interactive deployments through either a graphical or a command line interface. The script deployments can be pushed through any RMM or deployment tool that an organization might already have in place, including SCCM. And the background installations that might be pushed through a deployment mechanism can be silent and headless without any interaction or indication to the user that anything is going on. No reboot required, nothing for an end user to do that might interrupt their workflow or their day to day in any way. The installation itself is very quick. You can see it's actually already completed by the time we're done talking about it. Install was successful here, and we can see the status along the way, as well as whichever version got deployed for the system. While it's installing, it needs to download the latest files from the Cyber Crucible server, as well as call in to their API for a licensing check and initial configuration check, which is already done in the background there. And at this point, after the initial configuration and the licensing check and everything is checked out with the online servers, there is no required internet connection for protections to be in place by Cyber Crucible. That is very intentional for both speed and persistence, where Cyber Crucible can continue to function even in a bad environment where network connectivity may be compromised during an attack, either by an attacker or by a compromised machine or network state. And all of the detections, the behaviors, all the telemetry analysis, all the learning, and all of the actual protections that happen in under a couple hundred milliseconds happen all on the edge, on the endpoint, in the kernel without any need to check in with any outside authority or cloud service at all, meaning that as soon as an attempt at an attack or a file access or any memory tampering or anything that Cyber Crucible is going to be looking at happens, they immediately jump in and stop it without having to have any delays or any known signatures of any kind, because everything is completely based on all the behaviors that are happening on the operating system, all of the processes that are communicating with each other, all the handles that are being opened, all the attempted file access, network mounts, and anything of the sort. Cyber Crucible is monitoring all the time, such that by the time an attack is attempting to happen, there's already a full image and graph of trust on the system of what a process is doing and what they should be doing versus what they're attempted to be doing. Meaning that either unknown processes coming in and doing malicious actions off the jump or hijacked processes are treated the same regardless of what may have been happening before hijacking, and that the behavior is stopped no matter what. So now that Cyber Crucible has been fully deployed on this system, I'll go ahead and pull up a task manager just to show that the service is running and the resource consumption. We can go to services and just scroll down to the Cyber Crucible agent and go to details, and we can see that it's running using about 0% of the CPU, and the memory delta is pretty much consistent. Actually went negative there for a second, which is great, and we can actually dig deeper and see exactly what the working set of the memory is, and it's using about 27, call it 28 megabytes of RAM, which we can see just by looking up here a little bit is a fraction of what other processes on this machine are using. And I would wager that none of these are doing anything as complex as all the analytics and the protections that the Cyber Crucible agent is doing. Now, there's only two things left to do. One is the ransomware demonstration, and one is the AI acceptable use demonstration. I'll go ahead and run the ransomware last so that the AI tools are not put in any potential bad state by disconnecting a network card or anything that we're going to want to do while we're running malware. So I'll first go ahead and pull back up our documents. And I'll go ahead and run the MIP, the read MIP script here to read the labels of both our sensitive data as well as our no data classification file. And we can see with the sensitive data file, there is a tag, it's PII. This was created as of this recording today. And this label is in fact in place. And if we run the same script for the no data classification file, we'll see that there's just no MIP label for this file. And these documents are actually duplicates of each other, but one with the MIP label and one without. Notice the slight file size difference, but otherwise they're the same. And now we can just go ahead and run ChatGPT, and we'll try to upload both files and see the difference in how Cyber Crucible handles the actual data access at the endpoint level. So now with ChatGPT, go ahead and first just try to upload one of our protected files from our documents folder here. So we'll start with the MIP sensitive data docx, and we immediately see that there's just no permission to open the file, and that's because ChatGPT is actually being blocked from the kernel level by Cyber Crucible from opening this file. And we'll see that this is actually the same for any of the protected documents in this folder, that none of them are actually being able to be opened or be uploaded to ChatGPT for any unacceptable use. But if we go ahead and try to look at the no data classification docx, which is the one that had the no MIP labels, we'll see that ChatGPT is able to access that file perfectly normally, and we can even ask it just analyze this file. And we'll see that it is in fact actually HIPAA data, and it is not real HIPAA data, of course, but a fake document with fake information, and that it was able to actually access the file and read it and upload the data to the server. So if this was real HIPAA data, that MIP label being missing here would have actually caused a pretty severe data breach for uploading it to ChatGPT, versus when Cyber Crucible is actually protecting against the AI, either with a user manually uploading the files or potentially any iterative crawling and learning and uploading to shared drives or servers that might have happened without the user even knowing about it. So now to move things over to the ransomware demo, we'll go back to our images of our birds here. And what I'm going to go ahead and do is just minimize everything except for these birds. And I'm going to go ahead and cut the network card to this virtual machine since I'm about to be running ransomware. Twofold reason. One is just basic security hygiene, since we're about to be running known malware on a system, we don't want it to be network connected. And the second reason is, of course, we want to be able to demonstrate Cyber Crucible stopping this malware within that couple 100 millisecond time frame before a single file is able to be encrypted without any network connection, right? So I'll go ahead and pull out this sample of Hive onto the desktop, and this story, there's a story with this sample of Hive, and I'm going to go ahead and just run it as administrator and let it run this sample, and we can see it actually creates a couple of command prompts here while it's running, and actually starts telling us what it's doing while it's doing it, exporting key, and it'll go down a couple of lists. This sample of Hive is actually a couple of years old at this point. I believe it's from 2023, maybe even earlier, where it was used successfully against a hospital system in the United States. And this sample actually uses a process injection technique where it takes the Hive runner executable here and it takes this encrypted payload and it forces it via process injection into a trusted, privileged process that's already running on the machine, forcing something that's a sort of known, good, trustworthy process, like an SVC host or something similar, to actually start executing the malicious payload rather than running it from its own exe as a form of evasion for antivirus tools. We can see that even though Windows Defender is on and updated, it didn't kill either of these files because this one is not an exe, it's just an encrypted binary blob, and this exe effectively comes back as clean because it's not containing any malicious code. It's just the one that's selecting the process for injection and then doing the injection. And this Hive sample actually uh, tells us exactly what it's doing. It exports a key pair. It turns off any system services. This might be antivirus, backup solutions, security tools, anything that's alert or report aggregation, really anything that they think they might want to disable. This sample in particular actually iterates all services running on the machine and tries to stop them, including the Cyber Crucible service. Very important to note. Which obviously Cyber Crucible is protecting its own processes from the kernel, so this sample isn't able to kill it. Any shadow copies or system report restore points are deleted automatically by this malware, defeating any restoration capabilities there. And then, as a follow up, any remaining processes that weren't stopped by the system services are attempted to be killed. Again, Cyber Crucible would be one of these, but it is protected from even administrator or system level services trying to stop it. Then it will start to scan files and try to encrypt. And by now, there actually has been ample time where the disk would have been encrypted, but obviously our images are still completely fine and readable with no issue because Cyber Crucible stopped the attack within that couple hundred milliseconds. And we can see this is actually the key file that got generated here. You can see the name there is the same. It got exported. This is the key pair that would be used by the attackers if the attack was successful to try to pay the ransom. So we can see it did actually start to execute code. Not only did it do standard output here, but also did write the key file to the disk. But again, this is before it tried to actually do any of the access to the real data on the machine. And as soon as it started trying to read and of course overwrite any of the files that are on the disk, that's when Cyber Crucible kicked in and actually prevented the attack. And no matter how long we let this run for, it's simply not going to be able to encrypt.